All right, here's another problem from a calculus exam. We have this function, natural log of x squared plus 1, and we need to find the derivative of it first. So remember that the derivative of just natural log of x is 1 over x, and we're going to need to use the chain rule with that. So it's going to be 1 over x squared plus 1, but then we need to multiply by the derivative of the inside. So the derivative of x squared plus 1 would be 2x. So that's our expression for the derivative of f. It's going to be 2x over x squared plus 1. All right, cool. So the next part is find the equation of the tangent line at x equals 1. So we're going to need two things for that. We're going to need the both coordinates at that spot, which is pretty easy to get. We'll just, well, the x coordinate's obviously 1. And then for the y coordinate, we just got to plug it into the original function. So f of 1 is going to be the natural log of 1 squared plus 1. And of course, that simplifies to the natural log of 2. So the other coordinate here is the natural log of 2. All right, so we got both coordinates. Next, to find the whole equation of the tangent line, we also need the slope of the tangent line. And so that just means we need the derivative. We need to figure out f prime of 1. That's also pretty easy to figure out. That's 2 times 1 over 1 squared plus 1. It's easy because we already got the formula for the derivative. And looks to me like that's just 2 over 2. So that's just 1. So the slope of this line is 1. So there's our slope. And there's our point. So I'm going to use the point slope form of a line. It's y equals m times x minus x0 plus y0. So I'm just going to plug in my m value into that. So that m is going to be 1. And then the x coordinate is also 1. And the y coordinate was the natural log of 2. So that right there ought to be the equation of my line. And you can simplify that if you want. I guess, well, there's not too much to do. I guess you could do is just get rid of that times 1 because it doesn't do anything. But then there's nothing else you can really do here because there's no way to rewrite that. So there you go. That is the equation of that line. Now, just to check ourselves, here's the graph of that function. I think it's got a nice, interesting look to it. Kind of looks like a seagull that you draw in the background of a painting or something. And here's the point that they were interested in. Looks just like that. And here's the equation of the line that we came up with. And sure enough, that looks exactly like the tangent line at that spot. So I think we got it.